go on sending during this one, but without talking. Okay. Now today, I'll I'll tell you some bit about the how to do the derivative of a hyperbolic functions. Okay, let us take some example. Say you have to find out the ddx of sec h inverse modulus x. Okay, how to do this sum? Okay, modulus of x. So let, as usual, you have to do it. Let y is equal to sec h inverse modulus x. Okay, let. Now again let modulus x is equal to t. So this is nothing but sec h inverse t. So you find out dy dt. What is it? Minus 1 by t into root over 1 minus t square. And you put the value of x minus, so for positive values of t, it is nothing but x, and since 1 minus x square. Okay, and from here you calculate ex dt. What is the value? Ex dt. Can anyone tell? Or, okay, if you are not comfortable here, so let us make dt dx. What is the value of dt dx? That is ddx of, what is t? T is mod x. So it is nothing but mod x divided by x for x not equal to 0. Now this small line is very, very important. Okay, this small line is very, if you omit it, your entire sum is wrong. So what is our result? dt dx, that is equal to mod x by x. Now what is, you have to find out ddx of this quantity, So ddx of sec h inverse mod x. Okay, and that is equal to dy dt into dt dx. What is dy dt? Is minus 1 by x after transforming to the x into mod x by x. So this is your, now you just simplify it, you will get, just simplify it, you will get the result. Okay, so don't forget this, to write down this line. If you forget it, the entire sum, if it is, the result is like this, then also you will get a nice 0 in your answer, a nice 0. Okay, so someone has entered, I think. Let me hide the bit. Okay, all of you send your so this is about your just be careful about these small things. Okay, so I am going to the next page. Okay, now I am giving you more assignments. to do at home, and I will take it on. Okay, I'll take the later. First assignment section. Assignment. I have given 6 assignments, most probably, or 7 assignments. Okay. Today, this is assignment 1, dated 19/12/2020. Okay. Assignment 1. So find dy dx. Y is equal to cosec h inverse 5 root over x. Assignment 1, then y is equal to this one. Y is equal to sec h inverse cos. This is cos square x. Okay, to the power half. Then number 3, y is equal to cot h inverse e to the power x square plus 5x minus 6. It is in power, remember it. Then fourth one is y is equal to tan h inverse cot h x plus cot h inverse 2x. Okay, this is a typical sum. Take it, do it carefully. Then y is equal to sin h inverse root over x plus cos h inverse 2x. Go on writing. These are your assignments 1, set 1. These are all very good assignments. Okay. Then 1, 2, 3, 4, 5, 6. Y is equal to 1 by tan h inverse x. Okay. Okay, these are very good assignments 1, first assignments. Okay, you submit these assignments by say 23rd was the name, 25th 12 20. Okay, from 25th to 1st December, college will be, most probably college will be closed. So you can, but you can send the assignments during this time to, as I told you. Next page. Next page. Okay. Now I am assignment 2. Assignment, someone entered, most probably. Anyone who have entered? No. Okay, assignment 2, set. Prove the following. Prove the following. Okay, prove the following. Cot h inverse 2 by x, that is equal to sin h inverse bracket x by root over 4 minus x square. Number 2, tan h inverse x plus tan h inverse y. is equal to tan inverse x plus y divided by 1 plus xy. This is a formula, but you have to prove it. Next, sine h inverse bracket x by root over x square, sorry, root over x square divided by root over 1 minus x square is equal to tan h inverse x. Okay, so these three, submit it by 25th 12 to 20. Yes. Okay, next, fourth page. Okay, now integration. I have not taught yet integration of hyperbolic functions. Okay, so integration, that means indefinite integration and definite integration. Integration, that means, say, integration cos h inverse x, sorry, not inverse, cos hx dx, cos hx dx, cos hx dx, and sin hx plus integration constant. Okay, now you just put the value of the, now you know cos hx is equal to e to the power x plus e to the power minus x by 2. So put it here and do the integration, you will get the result. So similarly, integration sin hx dx, that will be cos hx plus c. Okay, integration sec h square x dx, that is equal to tan hx plus c. Integration cosec h square x dx, that is equal to minus cot hx plus c. Okay, now all this integration can be evaluated with this just by replacing sin hx with its expression sec square hx, sec h square x with this x with their expression, and so on. So you can do it easily. Okay, now I want to give you some today I am not going to give you these assignments on integration. I'll give you day after tomorrow, or any day afterwards. I want to show you this is assignment 1, page 5. Okay, let I am doing it, let something's let a is greater than 0. Okay, you have to find out integration 1 by root over x square plus a square dx. You have to do it. How to do this type of integration? Okay, now this type of integration always have two answers. Okay, remember this fact. This type of integration will all may have two answers. I don't know. Okay, how to do it? Let x is equal to a sin h theta. Okay, so dx is equal to how much? A cos h theta, as you know, and then theta equals to how much? Sin h inverse, sin h inverse x by a. Okay, so we are having this integration here, so put this value here. So we shall use this one here. So integration 1 divided by x, a square sine square theta, sine square hyperbolic theta, a square plus a square sine h square theta with a sine d, and in place of dx it is a cos h theta. So put a cos h theta. So put a cos h theta d theta. There will be one d theta. Okay. So a and a goes here. So this is equals to how much? 1 by, if you take a common and this a and this a goes, so 1 plus sine h square theta root over, and in the here it is cos h theta d theta. Okay, now 1 plus sine h square theta is equal to how much? As you know, this is with the integration sign. So integration cos 1 h theta d theta divided by, it is nothing but cos h theta, because sine cos square h theta minus sine square h theta is equal to 1, as I did in previous classes. So what is this? This and this goes. So this is nothing but theta plus c, that is equal to sine h inverse x by a plus c. So this is one answer of this integration. This is one answer. Okay, but there may be another answer. Okay, that you can do it. X by a is equal to sine h theta, and sine h theta is equal to nothing but e to the power theta minus e to the power minus theta by 2. Now you simplify this, and if you simplify this, you will get e to the power twice theta minus twice x by a e to the power theta plus, minus e to the power theta minus 1, that is equal to 0. So this is an equation. So it has a solution, and that solution is nothing but e to the power theta, that is equal to how much? 2x by a plus root over 4x square by a square plus 4 divided by 2. And if you simplify it, you will get x with a plus minus sign, x plus minus root over x square plus a square by a. Here it will be 2x by a. It will be just simplify. Just if you do the simplification, you will get this result. Okay. So e to the power theta. So what will be result? So e to the power theta is going to like this. So theta will be, just find out theta here. From here, just find out theta. You know it, how to do it. And you will get, here you will get theta. So you will get another answer. Is not it? You have got another answer. So integration of this is equal to theta plus c. So put that value of theta here, you will get another answer. Got it? Is there any question in it? Don't put this one. Just start from here and simplify it. You will get some theta here and put that theta here, and you will get answer in another form, in the logarithmic form. Okay, I'm writing down what you will get. You will get theta is equal to ln, as you did, x plus root over x square plus a square ln. Okay, that you will get x square plus a square. So there will be two types of answers. Okay, here I am just for your practice, I am just giving you another one. Okay, and do it yourself at home. Don't do it here yourself at home, but this is not assignment, this is for practice. Integration 1 by root over x square minus a square dx, and one answer will be equal to cos a inverse x by a, and another answer will be equal to ln to x plus root over x square minus a square. Okay, so this plus c, this plus c. So this will be two answers. Okay, and I can give you another one, 1 by root over a square minus x square. Remember this condition that a is always greater than 0. Okay, and this will give you answers dx with a dx. Answers like this: half log modulus a plus x divided by a minus x plus c. One answer, and another answer is 1 by a tan inverse x by a plus c for modulus x less than a, and 1 by a cot inverse x by a plus c, comma, as mod x greater than a. Okay, so this comprises three answers. One is this, another one is this. Now see here answers and questions. You see, there is no hyperbolic functions here. Okay, there is no hyperbolic. Check it. So I think there may be printing mistake here. Cot inverse h inverse here one, it will be h. Check it. I don't know, because in the material given it is there like this, but I think it is wrong. So check this one. Okay, now this one is due to a square minus x square. If modulus x is less than a, so this is positive. So this answer and these two may be the answer. But if modulus x is greater than a, so this becomes something this becomes something different, and answer is this or this. So there are two types of answers. If you don't do it, then I can do it, no problem. Okay, but remember always A is greater than, you must write it. Okay, now this is about your today integration of the hyperbolic functions. The rest I will give you in the form of the PDF format. Okay, now I want to shift, I want to go in the today's higher order derivative. HI. Today I'll just start it, higher order derivative. Now, not derivative of hyperbolic functions, but the derivative of all types of functions. Okay, higher order derivative. You know how to calculate dy dx. Say y is a function of x, and it may have many expressions. You know there are many types of functions are there, so you can define it as well as you can make derivations also. Okay, so this can be we shall represent here as y1, means first derivative. Y1 means first derivative. Okay, y1 means first derivative. So y1. Now this is the second derivative. Okay, naturally if we dy dx, it is a function of x, it is a function of x, dy dx is a function of x, so you can make a derivative, second derivative. Okay, so second derivative gives you y2. Just this is a representation. In this way, nth derivative, if it exists, we shall represent it by dny dxn as yn. Okay, so this is our new representation. Y1 means first derivative, y2 means second derivative, and yn. In this way, yn means the third derivative. So what is the significance of these higher order derivatives? Because sometimes you will see in book it is written as f dash x first derivative, then f double dash x second derivative like this, then f triple dash x third derivative, and so on. But for nth derivative, you can write down n dash 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 like this. So fnx, you'll see. So these are called higher order derivative. That is derivatives of more than first order, second order, or more than first order. Now this is sometimes it is referred to as successive differentiation. Okay, successive differentiation. So I can give you the examples. Say fx is equal to ax cube plus bx square plus cx plus d. ABC are real or complex numbers. So what is y1? That is equal to 3ax square plus 2bx plus c, d is 0. Then y2, the 3a 6a x plus twice b, and what is y3? It is 6a. So it has run up to y3, that means third derivative. After that, then y4 will be equal to 0. So that is a successive derivative, and after fourth derivative it becomes 0. It may so happen. So we are having some formulas to find out the derivative of our known functions. What are these known functions? Okay, known functions are, let say most familiar functions is x to the power m, where m is some integer, or m is some may have some values which is real value. What is this? Something happened here. Now say so you have to find out that dd x of x to the power m. What is this? M into x to the power m minus 1. Then what is the value of ddx 2 of x to the power m? That is equal to m into m minus 1 into x to the power m minus 2. But what will happen if it is, say, yn? So this function, now there are two types of values, that is m may be greater than n or m may be less than n. Okay. Now for m may be greater than n, then values, this value yn exists. And what will be this? M into m minus 1, then m minus 2, dot 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 dot, and continue so on, and it will be, you see, m minus n plus 1 into x to the power m minus n. This will be true. But if this happens, so sometimes yn will be equal to 0 when m is equal to n. So, sometimes happens that m becomes equals to n, and after that it becomes 0 because m is less than n, but you have to do the integration differentiation up to n, so yn will be equal to 0. So in this way you have to calculate. Okay, this is a known function, everybody knows. Another known function is a to the power x, okay, where a is a real number or complex number. So we shall study this one. We shall study this one in detail in the next from the next classes. Okay, and you are having 6 types of, you are in your syllabus, 6 types of functions. That is number 1, algebraic functions. Number 2, log functions, log. Number 2, exponential. Number 3, trigonometric functions. Number 4, number 4, number 5, transcendental functions. Transcendental functions. Okay. Now, what is called transcendental functions? Those functions are not like this, then they are called transcendental functions. Okay. And polynomials in algebraic functions, then log functions, exponential functions, trigonometric functions, and one I forgot, that is trigonometric functions and inverse circular functions. Inverse circular functions. Inverse circular functions. And 7 is inverse hyperbolic functions. Hyperbolic functions. And trigonometric functions are exponential functions. In case of exponential functions, hyperbolic functions comes into play because it involves exponential part. Okay. So from next class, I shall start doing on higher order derivatives as well as some. Now my next class will be on, today is 19th. So I'll check the date and I will give you the notice. Okay. In due courses, you will get the notice. Now today, I want to tell you something more, not about this. Some of you have expressed difficulties in plotting the curve. Okay, so let me go to the next page. In plotting the curve of y is equal to sine hx. Okay, but only one people among you have sent me the curve. This is very important because from this you will understand what is the domain and range of the functions. Okay, I have given only 2 assignments. Now this is one assignment, nobody, only one person have submitted, but you have to submit it by what was the date? That is 23rd. Okay, so one thing is that someone is asking but say I have given x is equal to minus 10 to 10. Okay, so there are 20 points. So first point is say minus 10. Okay, so put here minus 10, you will get, so first point is x1 y1, you plot it. Then second point is x2 y2, you plot it. You will get a curve in your system, you will get a curve, and the curve looks like it looks like this. Okay, it will pass through the center and it will go like this, but someone has got like this. Is correct, is correct. Some may get like this, is correct. Okay, because you have chosen your scale. That shape of the car has been different for choosing your, for choice of your scale. If you choose the scale, it may look like this. If you choose the scale in such a way, it may look like this, or so on. Okay, so don't, but it must have first quadrant and second quadrant. Nothing will come here. Okay, so I need the card to be sent to my as an assignment, and this third assignment today I am assigning you. This third assignment is y is equal to cos hx. You send it by 25th. Send it by 25th 12/20. Okay, remember this. After 25th, I will not consider marking. Understood?
Sir, the points are minus 10 to 10.
Points are minus 10 to 10. 20 points, you have to draw it. Okay, cos hx. And each week you draw one. After 2 or 3 you have drawn, you will be experienced enough to draw the curve, and you will be able to find yourself. You just remember the curve, shape of the curve. You will be able to find yourself the domain and range of these hyperbolic functions. In this way, you can find out the domain and range of any function by drawing the curve. Okay. Okay, then today it is okay. I'm just now, anyone needs the board again? Any?
Yes, sir.
Board? There is the first. I have told you to recapitulate this one. Remember this. You have to mention it. Okay. Next one is then number 2. Assignment 1. 1, 2, 3, 4, 5, and 6 by 25, 12, 20. Then number 3. Assignment 2. Okay, these 3. And then number 5, integration. Okay, I told you to do the practice, but these are not assignments. Okay, then and I have done one integration like this. You are having 2 answers. Okay, one answer is here and another answer is here, starting from here. Okay, then you are having, I have given you to do the practice. Not, these are not assignments. Okay, then number 8, higher order derivative I have started. I have defined y1, y2, y3 and yn and so on. Just tomorrow I will, next class I will be elaborative enough. Okay, this is one function I did, number 10, and this is about your what, this problem. I just give you assignment 3, y is equal to cos hx, with the same interval, with the same points. Okay, so this is about your today's class. Have you sent your roll number and name? Yes. Okay. Thank you. You will get this recorded recording. I have given the second lecture in your